Okay, this is number 9. It's from a book. It's chapter 2, and it's a new type of problem, and it's confusing, and you might not get it the first time you watch this video, so rewatch it and then solve it 3 times. So, a tourist being chased by an angry bear is running in a straight line toward his car at a speed of 4 meters per second. The car is distance d away. The bear is 26 meters behind the tourist and running at 6 meters per second. The tourist reaches the car safely. What is the maximum possible values for d? So we need to draw a picture, like always. But I am actually going to draw 2 pictures. And you just kind of have to know when you have to draw 2 pictures. And this is the instance where you want to. It's hard to distinguish that, but okay. So we have me. And I'm going to call this T. Uh-oh. That's the moment that I realize there's an angry bear running towards me. Very angry. My car is right here. So I am running at 4 meters per second. I'm going to call this, I'm going to do my step 2 over here, my knowns. V me is going to be 4 meters per second. Our angry bear is running at, so that was V me. This is V bear. So V bear is going at 6 meters per second. What else do we know? The car is distance d away. And the bear is 26 meters behind the tourist, me. So we got this going on. The tourist reaches the car safely, thank God. What is the maximum possible values for d? So we are ultimately looking for d, and now is when I'm going to write our second picture. So we get to our car safely. This is going to be t safe. The time that we became safe from the bear. So we want to know the maximum possible values of d. How far can I be from the moment that he starts chasing me and I can get safely to my car? That kind of means that what is the moment that we both reach the car at the exact same moment? It doesn't, it can be the exact moment, because as long as I get there, we're safe. Bear can be there. As long as I'm at the car, he can be there too. I don't care. So, yeah, that is kind of what's going on. That is our picture. So let's maybe do our step 2. Well, I mean, this is kind of it. I mean, our unknowns would be D. That's what we want. 26 meters. I don't know how to express this. I don't know. I'll just call it X. Whatever. That would be 26 meters. That was step 2. Now let's go to step 3. Let's think about our equations. We are just dealing with kinematics. There's no forces, So we're not even going to think about ma equals f. Don't think about that. We don't have any forces. We just have kinematics. So let me write down our kinematics equations. V final equals V initial plus AT. Displacement is V initial t plus half AT squared. V final squared minus V initial squared equals 2AX. It's going to be 1, 2, and 3. Let's and this is where it gets kind of hard to explain. We want to know distance, right? So first of all, we're not even going to look at number 1 because that doesn't even have distance in it. So no. Number 2. We want distance. We don't really know the time. We don't know how long it took, how long it can take for us to go from right here to here. We don't really know. So that's kind of like a iffy. Acceleration, we don't have any acceleration. So we're not even going to bother evaluating because that just, if we don't have any acceleration, that just becomes 0. So 2 is like a, I don't know yet. 3, V final. I mean, but V final, we're looking at the exact moment we come to the car. So I just want to be clear, our velocity when we reach here is still going to be 4 for us. It's still going to be, what was it? 6, yeah. It's still going to be 6. It's the moment we get there. We're not going slower. We want to stay at the pace that we were going. So V final, I just want you to imagine this. So we have 0, right? Oh, sorry, oops, no, that's 0. We were going, oh, what did I do? Okay, no. Okay, we were going at 4. No. We reached the car, V final at 4. V initial, we were 4 to AX. We want to find X, but this just becomes 0. So X equals 0? No, that doesn't make sense. That's not even correct. So based on that, I'm going to use equation number 2, but it's not going to be straightforward like always, and that's the difficult part of this problem. So we have the displacement is velocity times t, and I hope you guys can see that this is just a rewritten version of how we usually say that velocity is distance over time. Distance, that's just another word for displacement x, right? And if we just multiply both sides by t, we just get x equals vt. That's that. I hope you guys can see that. Anyway, we want to find maximum possible distance. Okay, so this is a part where you just kind of have to swallow and be like, okay, this is how you solve it. I mean, well, this is how I solve it. I don't know how other people solve it, but this is just how I solve it. The distance that we travel, that's d, but the distance that the bear travels is d plus x, right? We kind of get like a head start. So the x is different for us and the bear. V initial, our velocities, we have different velocities. We're going at 6. Bear's going at, no, we're going at 4. Bear's going at 6. What about the time? From the time uh-oh to time, is that how you spell uh-oh? Oh, uh-oh. No, that's not right. Okay, sorry. The time, from time uh-oh to time safe, the same time has passed for the bear and I. t is the same for both of us, right? So I can say that the time for bear is the same as time, how long I ran for, right? How long I ran for is the same amount of time as how long the bear ran for. So we know this. Do you think we can somehow use this equation to put in some values? So I'm going to rewrite this as t equals distance over velocity. That's just algebra. I hope I'm not skipping too many steps. So from that, I'm going to rewrite t. So the the distance, the overall distance that the bear travels over the velocity of the bear should somehow equal the distance that I travel over my distance, my velocity, sorry. Still kind of wonky, I know, but let's just start putting in our values. So the distance that the bear travels, that's not just d, right? D bear. The distance the bear travel goes from here to here. That's going to be d bear. So I have to write d bear as d bear, d plus, I know I rewrote this as x, but I'm just going to write 26 here. D, that's how long, that's how much the bear has to travel in order to get to the car at the exact same moment that we get there. The velocity of the bear, that was 6, right? Now, what's the distance that we have to travel? That's just d. So I'm going to write d. What's our velocity? Ours was 4. Okay, so we just have one variable in this equation that I made here. So we just need to solve for d, and that's just algebra. So first step, I'm going to multiply both sides by 4. So I'm going to get 4d plus 26 over 6 equals d. Now I'm going to multiply both sides by 6. So it'd become 4d plus 26 equals 6d. I'm going to distribute the 4. So I get 4d plus, is that right? I hope that's right. I don't have the answers for this. Do I have the answers for this? I don't think I do. Yeah, I don't have the answers for this. So, oh, this is scary. We want to solve for d. So I'm going to subtract 4d from both sides. So I get 104 equals 6d over 4d. Oh, I think I'm on the right track. Awesome. So 104 equals 2d. Divide both sides by 2, and you get 52 meters. That is the maximum distance that we could be away from the car and sprint towards the car and get at the car at the same moment the bear gets to the car. Don't think about like the time you have to open the door or whatever. Okay, that's how you solve this one. I know it's less intuitive, but a little more intuitive in a different way. Yeah, solve this one many times. It gets easier, I promise.